Today's video lesson is going to be on rounding and truncation. If you wish to take part in any of the tasks I'm going to pop on the screen today, grab yourselves a pen and something to write on. If you want a little bit longer to read through the task board so you can see what's coming up, then pause the video now and hit play when you're ready to jump in. First off, let's look at rounding. Rounding is where we simplify a number by reducing the number of digits. We do this by working out a simpler number that it's closest to. For example, round 57 to the nearest 10. Well, the 10s either side of 57, if we go to the 10 below it, that would be 50, and the 10 above it would be 60. 57 is closer to 60 than it is to 50. So if we're going to round it to its nearest 10, we're going to round it to 60. Let's have a look at some example pairs. Now, something that might really help you with this is a little diagram that explains when digits cause a number to round up or stay the same. So if you see the digit 5, 6, 7, 8 or 9, these are the 5 digits that cause a number to round up. However, if you see the 5 digits 4, 3, 2, 1, 0, so we've got an even split, 5 digits above and 5 digits below, that's when it causes the digit to remain the same. Now notice my language here. I refer to rounding up but staying the same. Nowhere do I refer to rounding down. Rounding down can lead you to misunderstand what's going on, and some people would then reduce the number. And we don't want to make a number smaller, we want it to stay the same. Let's have a look here. We've got round 231 to the nearest 10. The nearest 10 either side, we could have 230 below or 240 above. And our job is to decide if 231 is nearer to 230 or 240, because both of these numbers are in the tens. Notice there's nothing in the ones column. 231 would be way down here, right after 230. So 231 is closer to 230. So when we round it, we would say it's 230. But the way we're going to look at this, and the way we'll look at future rounding after this, is to have a look at the number. First of all, we're rounding to the nearest 10. So let's underline the tens column. So this is the digit I'm interested in. And then what we do is I say we peek next door and we see what this digit is. And then we refer to these digits I've written at the side. So the 5 to 9 means the 3 will round up, the number in the tens column. And the 4 to 0 means it will stay the same. Well, when we peek next door, we've got a 1. And a 1 is one of the digits that tells me it will stay the same. So it will stay as a 3, and our answer will be 230. Likewise, this second one, 687 to the nearest 10. So the number in my tens column is the 8. If I peek next door, I've got a 7. Now, according to my numbers over here, a 7 makes the digit next to it round up. So this 8 isn't going to stay as an 8, it's going to round up 1 to a 9. So that means to the nearest 10, this would be 690, which makes sense because our choices were between 680 below or 690 above. And 7 is closer to bringing it up to the 90 than going back down to the 80. Here are 2 questions for you to have a go at. Pause the video and hit play when you're ready to see the answers. 563 to the nearest 10 would be 560, and 429 to the nearest 10 would be 430. What about to the nearest 100? So I'm going to underline my hundreds digit and then peek next door. A 2 tells me that the 6 is going to stay the same, so to the nearest 100 it would be 600. I'm thinking about this logically. My lower choice when rounding this to the nearest 100 would have been 600, my upper choice 700. 628 is somewhere between 600 and 700, and our job is to work out, is 628 closer to 600 or closer to 700? And it's closer to 600. Then we've got 273 to the nearest 100. So the 100s either side of that would be 200 or 300. Is 273 closer to 200 or 300? Well, let's have a look. Here's my hundreds digit. It's currently a 2, I'll peek next door and I can see a 7. 7 is one of the digits that causes the 2 to round up, so it will become a 3. And so 273 is closer to 300 when we round to the nearest 100. Here are 2 questions for you to have a go at. Pause the video and hit play when you're ready to see the answers. 821 to the nearest 100 is 800, and 684 to the nearest 100 is 700. And then we have decimal numbers, rounding to decimal places. Now when the question asks us to round to 1 decimal place, that simply means it wants us to write our answer with 1 number after the decimal point. And so I've underlined that digit, the 1 digit after the decimal point. I'm going to peek next door. I can see it's a 3. 3 is a digit that causes the number to stay the same. So to 1 decimal place, this would be 0.5. Now, just a reminder that we could, like with the previous questions, replace the missing digits with zeros. So the 3 becomes a 0 and the 1 becomes a 0. But in decimals, any zeros that come after the last non-zero digit are pointless. We don't have to write them down. So 0.5 is a good enough answer here. We've got 2.75 rounded to 1 decimal place. So here's my first decimal place. I'm peeking next door. I can see I've got a 5. 5 is one of the digits that causes my number to round up. So the 7 will become an 8. And as you can see in both of these answers, I've got 1 digit after the decimal point. So we call that rounding to 1 decimal place. Here are 2 for you to have a go at. Pause the video, hit play when you're ready to see the answers. 0.315 to 1 decimal place is 0.3. And 5.48 to 1 decimal place is 5.5. And now we're rounding to 2 decimal places. So now I want 2 digits after my decimal point. So the 6 would be the first digit, the 2 would be the second digit. We've got round 12.624 to 2 decimal places. So I've underlined the second digit or the second decimal place, and then I'm peeking next door. I can see it's a 4, which is one of the digits that causes my number to remain the same. So it will be 12.62. Notice my answer's got 2 digits after the decimal point, so that means it's got 2 decimal places. Then we've got round 172.3514 to 2 decimal places. So 2 decimal places takes me to the 5. I peek next door, which is a 1, and a 1 is one of the digits that causes the number to stay the same. So the 5 is just going to stay as a 5. So our answer is 172.35. Here are 2 questions for you to have a go at. Pause the video and hit play when you're ready. Round 15.123 to 2 decimal places becomes 15.12. And round 207.8601 to 2 decimal places will be 207.86. And another type of rounding is when we are asked to round to significant figures. Now, significant figures are the most important figures or digits within the number. That means the largest place value columns. So my first significant figure will be the largest place value. So in this case, it's in the thousands. We've got thousands, hundreds, tens and ones. Thousands are obviously much bigger. So the first significant figure here is the 2 of 2000. And just like before, if I only want 1 significant figure, I'm going to underline that first significant figure and then peek next door. 4 is a digit that tells me the 2 stays the same, but I can't just write 2 because this is a number in the thousands. So I put down the 2 and I fill the remaining digits with zeros or placeholders. So 2,456 to 1 significant figure is 2,000. This next one, round 23.785 to 2 significant figures, the tens and the ones would be the largest place value in this number. So they are the first 2 significant figures. So the 2 in 20 is the first significant figure, the 3 in the ones is the second significant figure. We're then going to peek next door. We've got a 7. 7 is a digit that would cause the 3 to round up. So to 2 significant figures, this number would be 24. And as we've already talked about, I could put 0.000, but any zeros after the decimal point are unnecessary. Here's 2 more questions for you on rounding. Pause the video and hit play when you're ready. 36,821 rounded to 1 significant figure would be 40,000. And 14.8143 rounded to two significant figures would be 15. And then we've got this idea of truncation. We have rounding, which is always about considering how far the number is from the measure below and the measure above and going to the nearest one. Truncation doesn't do that. Truncation just looks at the digits presented to you and gives the answer based on that. It's simply where we chop any unwanted digits off a number without considering their rounding power. So we don't even think about whether the digits would cause it to round up or stay the same. We don't look at it at all. For example, if I were to truncate 263 to the nearest 10, I would say the 6 is my tens digit. I don't care what comes after it, whether it rounds up or stays the same. I'm not interested. So it's just going to be 260. So regardless of if that 3 would cause it to round up or stay the same, we don't care. We're just interested in that it's 260. Don't care about that last digit. And if we look at this one, truncate 268 to the nearest 10, well, if this was rounding, that 8 would cause the 6 to round up to a 7. In truncation, we go, well, there's my nearest 10, 260. I don't care what this last digit is. I'm not looking at whether it's rounding up or staying the same. So again, just 260. So hopefully what you can see is regardless of the rounding power of that last digit, we haven't taken it into account with truncation. We're just chopping it off and looking at the digits we've got. And with decimals, truncate 17.521 to one decimal place. Well, there's my one decimal place. I don't care what the other digits are. So it's just going to be 17.5. Even if the digit after the 5 normally in rounding would cause the 5 to round up to a 6, in truncation we don't care. We don't look at what the digits are after, it doesn't matter to us. We're just chopping those extra digits off. So let's have a look at a few examples. Truncate 4,582 to the nearest 100. Well, the 5 is my hundreds digit. I don't need to peek next door and see what comes next. It's just going to be 4,500. And truncate 256.872 to one decimal place. Well, my one decimal place is the 8. I don't care about the rounding power of those extra digits, so it's 256.8. Here are two questions for you to have a go at. Pause the video and hit play when you're ready to see the answers. If we truncate 3,275 to the nearest 100, we would get 3,200. And if we truncate 84.6701 to one decimal place, we would get 84.6. If we truncate 386 to one significant figure, my 3 is my one significant figure in 300. I don't care about the rounding power of the other digits, so it's just 300. Whereas if I'd have rounded that to one significant figure, it would be 400. So you can see the words truncate and round have different meanings, and it's important that you know the difference between those two meanings. Truncate 3.14159 to three significant figures. Well, my significant figures are the 3, the 1 and the 4. I don't care what the remaining digits are, so it will just be 3.14. Last two questions for you. Pause the video, hit play when you're ready to see the solutions. 9,024 to one significant figure is just 9,000. Truncate 5.3304 to three significant figures would be 5.33. Let's have a go at some multiple choice questions now. Watch out for the language used. Is it round or is it truncate? I will put a 10-second timer on the screen, but if that doesn't work for you, you can just ignore it, pause the video and hit play when you're ready to see the solutions. We've got round 4,526 to the nearest 10. Here are your options. The answer to that one was C. Round 64.3802 to two decimal places. Here are your options. answer to that one was B. Round 86.9 to one significant figure. Here are your options. The answer to that one was D, and truncate 38,500 to two significant figures. Here are your options. And the answer to that one was B. Here are a few questions for you to have a go at. You have got a mixture of rounding and truncating, and you've got a mixture of the nearest 10, 100, 1,000, decimal places and significant figures, so we can really test your ability across a wide range. Pause the video now and hit play when you're ready to see the answers. They will be coming up on screen in just a moment. And here are your answers. Feel free to take a bit of time to mark those and see that you've got them correct. If there's anything you're not sure about, feel free to go back and watch one of the examples again to support your learning. Or if you need specific guidance about a question, drop it down in the comments below. We always aim to answer every question and comment related to the content of the video. Remember, we are here to help you, so do just reach out. All that's left to be said is a big well done for taking part in this video lesson today. All the extra revision you do for your exams will benefit you greatly. If you enjoyed the video, remember to give it a thumbs up and subscribe for more video lessons, also that you are able to find us if you need to reach out for help in the future. If you also like short form content, we also post revision quizzes and tips over on TikTok and Instagram. I'm Charlotte, thank you for watching this video.